Hi folks, Chris McClure. We now move into chapter 1 today, where we are going to review how to solve linear equations. So here's some things to help us in our quest. First of all, remember that equality between two numbers, and by the way, x is a number, we just may not necessarily know the value of it, but this is the reflexive property of equality that says if 3 is equal to x, that means x is equal to 3. So we oftentimes, though, like to put the variable on the left-hand side and then the number, as in the fixed number, like 3, on the right side. What we also do in our quest to solve equations is that we simplify both sides of an equation by maybe expanding and collecting like terms. Like you see here, x plus 2 plus 6, well, you drop the parentheses and combine the 2 plus 6 to make 8. On the right-hand side, you can drop the parentheses and combine 2x plus x to make 3x, where 2x and x are like terms. And then, of course, you can proceed to do what you need to do in order to, isolate the x term. So, for example, if you have 3x minus 5 equals 4, you can add 5 to both sides in order to eliminate that minus 5 on the left, because the opposite of subtracting 5 is to add 5. So when you add 5, you come up with an equivalent equation. You may have to multiply both sides of an equation by the same amount. Like, for example, this equation right here, you can multiply both sides by x minus 1. So that will just give you the equation that 3x is equal to 6, which means x equals 2. Also, when you are solving an equation, you may have the product of two or more factors equal to 0. In which case we invoke the zero product property that says that if you have the product of two or more factors equal to 0, that means at least one of those factors equals 0. So what we typically do is we'll set all of the factors equal to 0 and solve for x. So if x times x minus 3 equals 0, that means either x equals 0 or x minus 3 equals 0, in which case x equals 3. So there would be two solutions to this equation, 0 and 3. So let's put all this together and solve some equations. We'll start off with 4x minus 7 equals 13. All right, we will now add 7 to both sides to just get 4x by itself. Now on the left-hand side, the 7's cancel. The minus 7 plus 7 is 0. Why did we choose to add 7 to both sides? So that we can get the 4x by itself. And the opposite of subtracting 7 is adding 7. On the right-hand side, 13 plus 7 is 20. So we now have the equation 4x equals 20. The opposite of multiplying by 4 is to divide by 4. So we will divide both sides of the equation by 4. Remember, in solving equations, what you do to one side of the equation is what you have to do to the other. So we'll divide both sides by 4. And 20 divided by 4 on the right-hand side equals 5. So we come up with the solution 5 for x. And, of course, we should always check by going back and substituting 5 in for x into the original equation. 4 times 5 is 20. 20 minus 7 is 13. Oh, yeah, that is true. So here's the steps for solving an equation. First, observe any restrictions on the domain of the variable. Make sure that we're not, taking the square root of a negative number, for example, or dividing by 0. And then what we're going to do is, add the same amount to both sides, subtract, multiply, divide. In other words, what you do to one side, you do to the other to produce a sequence of of equivalent equations. Now, what does that mean? Well, the equation that x equals 5 is equivalent to the statement that 4 equals 20, which is equivalent to the equation that 4x minus 7 equals 13. The only thing that separates this equation from this equation from this equation is the fact that there's maybe a common multiple on both sides, or a common factor added or subtracted or whatever. All right, and again, if you have the product of two or more factors equal to 0, then you invoke the zero product property by setting all the factors equal to 0 and solving for the variable. And then lastly, check your solutions. It very well could be that at least one of the values of x that you have found may not necessarily solve the equation. All right, so let's go ahead and get into the meat and bones of this. Here is the official definition of a linear equation with one variable, where a and b are just fixed real numbers. And you can write it in this form. That means you have a linear equation in one variable. And how do you solve it? Again, use everything that we've learned so far. You can, take this equation, expand out both sides, or you can go through and multiply both sides by the least common multiple of any denominators or fractions that are involved. Notice these fractions, 1/3 and 1/4. Least common multiple of those denominators, 3 and 4, is 12. So we could multiply both sides of the equation by 12, which will clear out those fractions. 12 times 1/3 is 4. 12 times -3 is going to be -36 here. On the right-hand side, 12 times 1/4 is 3. Okay, and then, like I said, expand out both sides of the equation. 4 times x minus 1 is 4x minus 4 minus 36. But you see here, and 3 times 3x plus 2 is 9x plus 6. And, maybe combine like terms. -4 minus 36 is -40. Maybe add 40 to both sides. Maybe subtract 9x from both sides. So you get all the x's on the left-hand side and all the constants on the right-hand side. And then finally divide both sides by -5. So our solution here is -46/5. And then, of course, to check your answer, you can go ahead and plug -46/5 in for x there, and verify that both sides of the equation are equal to the same number. Now, not all of your numbers in an equation are going to be nice, easy fractions or integers or whatever. Like, for example, this equation here. But look, 3.81, 12.231, 23.03 are all just good numbers. Maybe you can add 4 over 12.231 to both sides and then divide by 3.81. as in this number right here, so we get x by itself. And then you can plug this big old fat number into your calculator, and that should approximately be equal to 5.96. Okay? Why don't you try this on your calculator right now to verify that you get the same thing? Let's try that. I've brought my calculator with me, so we're going to take 23.03 minus, and let me go back, 4 over 12.231 there. Did I get it? I think so. I'm going to hit enter here, and then I'm going to divide that by 3.81, and let's see if we get the same thing. 5.96 approximately. So there we go. Okay. So if we did this right, 5.96 is the number that we would plug in for x into the original equation, and we would have a true statement. Now, not all of your equations are going to look exactly in the form of ax plus b equals 0. But with a little bit of algebraic manipulation, you can turn them into linear equations. So, for example, if you have 3x minus 1 times x plus 2, and that's equal to the product of x plus 3 and 3x minus 2, you can multiply out the left-hand side, multiply out the right-hand side, subtract 3x squared from both sides. Of course, they cancel, leaving you just with this linear equation. And of course, you can maybe, add 2 to both sides, subtract 7x from both sides, divide both sides by 2. So this is an example of an equation that leads to a linear equation. Here's another example of an equation that leads to a linear equation. Folks, when you have equations involving fractions, multiply both sides of the equation by the least common multiple of the fractions in order to clear those fractions. So to multiply both sides of the equation, in this example, by x plus 3 times x minus 1. And you will see that those fractions are cleared. When you multiply out the left-hand side, the x minus 1's cancel, leaving you with 2 times x plus 3, which is 2x plus 6. On the right-hand side, notice the x plus 3's cancel with that first multiplication, and that x plus 3 times x minus 1 cancels by multiplying by the second fraction, giving you 3 times x minus 1 plus 1. Expand out that right-hand side, you have minus 3 plus 1, which is minus 2. Maybe you can subtract 6 from both sides, subtract 3x from both sides, and then multiply or divide both sides by negative 1. And you end up with x equals 8. Now, if you came up with 1 or negative 3 in your solution, then you would have to eliminate that as a possible solution, because you cannot divide by 0 in the original equation. But in this case, there's no problem. You'd have 2 divided by 7 is equal to 3 over 11 plus 1 over the product of 11 and 7. Whatever that is. And hopefully that's a true statement. Here's another example. Again, multiply both sides of the equation by the least common multiple of the denominators, which is x minus 2 in this case. And I'll quickly go through this. Expand out the left-hand side and the right-hand side. Multiply it out, add 2, divide by 4, and you get x equals 2, except 2 is not a solution, because if we were to plug in 2 for x there and or there, you'd be divided by 0. So you'd have no solution, okay? So always plug in what you propose to be the solution back into the original equation and see if that gives you an equation that could be true. In this case, then the answer is no, because you cannot divide by 2. We understand there's a linear relationship between Fahrenheit and Celsius temperature scales. If you want to convert from Fahrenheit to Celsius, just plug in your temperature in Fahrenheit, subtract 32 degrees, and then multiply by 5/9. And then vice versa. If you know your temperature in Celsius, plug it in for C there, and then multiply by 9/5, and then add 32 to find Fahrenheit. So if, for example, Celsius temperature is negative 10, then you can go ahead and plug in negative 10 for C. But because of the fact that we've got 3 temperatures, it would probably make more sense if we take this equation and solve for F in terms of C. But again, maybe multiplying both sides by 9, dividing by 5, and adding 32. So you end up with 9/5 C plus 32. So plug in your temperature for negative 10 for C, and 9/5 of negative 10 plus 32 works out to be 14 degrees Fahrenheit. So when it's negative 10 outside, that means it's 14 degrees Fahrenheit. If the temperature is 0 degrees Celsius, that corresponds to our freezing point of 32. If the Celsius temperature is 40 degrees, that turns out to be a blistering hot at 104 degrees Fahrenheit. The reason we get that is because you take 40 degrees Celsius, multiply by 9/5, and then add 32. We could talk about solving linear equations that could be modeled, or talk about solving problems that could be modeled by a linear equation. So here's a quick summary of the steps that you could use to answer just about any mathematics application problem. I would probably highlight step number 1 is to read your problem carefully multiple times and think about what it is that you know and what you don't know. Maybe draw a picture to help you understand the relationships between everything. Figure out your variable here. Make a list of all your known facts, and again, write down a model that shows the relationship. And what we mean by model is maybe an equation or two to give relationships between things that you know and don't know. And then solve your equation for your unknown quantity, and then double check your answer. So for example, suppose that we've got an investment portfolio worth $16,000. Part of the $16,000 is invested in stocks, the other amount is in bonds. So together, stocks and bonds total is $16,000. Now suppose that we don't know how much is in stocks and we don't know how much is in bonds, but we're told that the amount invested in bonds is 1/4 of that invested in stocks. Take a look at this second sentence. If the amount invested in bonds is 1/4 of that invested in stocks, take a look. Let's go ahead and figure out an equation. We don't know how much is in stocks, and we don't know how much is in bonds. What we could do is we could let X be equal to the amount invested in stocks. And if that's the case, then 16,000 minus X will be the amount that's invested in bonds. And then here we could write the equation that says that the amount invested in bonds, 16,000 minus X, is equal to 1/4 of the amount that's invested in stocks. Remember, X is the amount that's invested in stocks. So 1/4 X is the amount that's invested in bonds. So we have this equation now. Now take a hard look at it, make sure it makes sense to you. Once you're satisfied with that equation, which by the way is a translation of this statement right here, the amount invested in bonds is 1/4 that invested in stocks. Here it is, almost on a word-by-word basis using mathematical notation. Then you could solve that equation for X. The hard part is setting up the equation. Now you solve this equation by adding X to both sides, and 1 plus 1/4 is 5/4. So X plus 1/4 X is equal to 5/4 X, and then multiply both sides by 4/5 to solve for X. Now 4/5 of 16,000 is 12,800, and 12,800 therefore is the amount invested in stocks. Take 1/4 of that, and you get 3,200. Or you could subtract from 16,000, you get the same thing. Excuse me. So, to just double check our work, it is useful to go back and verify that our proposed solution actually solves the problem. The amount invested in bonds is 1/4 that invested in stocks. So if we're saying that 12,800 is the amount that we invested in stocks, 1/4 of that is 3,200, or whatever the difference between 16,000 and 12,800 is. But then just double check that the sum of the 3,200 for bonds and 12,800 really is equal to 16,000. In other words, just double check your work, make sure that your answers make sense. All right, got another question for you. Suppose that we've got this individual who earns $440 in 1 week by working 50 hours. Now, we don't know what his hourly wage is, but we know that any amount of work done in excess of 40 hours in 1 week, he's paid time and a half overtime. Now, let's take a look. Do we have enough information to solve the problem? We do. What we could do is we could let X be equal to the amount of money he's earning per hour. That's his hourly wage. And now we can create a little table if you want. It doesn't have to be this fancy. But we should recognize that whatever his hourly wage is, X, well, 40 times X is going to be equal to his normal weekly salary if he's not working overtime. But for every hour that he's working overtime, in this case 10 hours, he'll get paid time and a half. And we will express it as 1.5 times his hourly wage. And if you multiply that by 10, it'll be 10 times 1.5, which is 15, as in his weekly salary for that set of 10 hours overtime will be 15x. And then you can then add his normal regular salary together with his overtime salary. 40x is his regular salary and 15x would be his overtime salary. Then that should be equal to his gross salary for the week. 40x plus 15x is 440. That's the hard part, setting up the equation. Once you set up the equation, then you could solve for x. All right, it works out that x is 8. As in, he's being paid $8 per hour. Then what we could do to double check our work is to verify that he really should have been paid $440. If he were to work a straight 40 hours, 8 times 40 is 320. And then if he does 10 hours of overtime, now overtime, time and a half, if you take 1.5 times 8, you get 12, right? 3 halves of 12 is, three halves of 8 is 12. So he'd be making 12 hours per hour for overtime. 10 times 12 is 120. 320 plus 120 is 440. So that verifies our answer. So we just refreshed our memory on how to solve a linear equation, looked at some application problems. These were the steps that we used in solving our equation. Any questions? Now I'm going to be posting a quiz for chapter R on my math lab today. And tomorrow during the lecture I will point out exactly where it is, but I'll tell you where it is right now, or where it's going to be. If you were to go into the course on my math lab, click on Math 121 there. Now all your homework is under this link right here for homework. But if you were to go down to this link right here, well, there's nothing for me to show you because I haven't come up with the quiz yet. But when you see my quiz, the chapter R quiz, it'll be up here above the sample tests and quizzes. Now the sample tests or quizzes, you could do this for fun, just to check your understanding, but it's not going to count for points. But the quiz that will count for points will be posted up here. I will show you tomorrow after I get this posted later today, okay? So take care, folks. I'll post some homework for section 1.1, and I'll talk with you tomorrow. Have a good day. See you next time.